I could explain mathematics to my children in the same way that Brahmagupta would have explained mathematics to his children. Some of us learn with our eyes, some of us learn with our ears, some of us learn with our hands, our touch. And if numbers represent counts or measures of quantity or energy, the least number representing a quantity you can have is shunya.
Hello my dear student, I am Shweta Sharma, eSaral Mathematics faculty. Today on account of National Mathematics Day, I have a very special guest for you. Here in this session, Mr. Jonathan Crabtree from Melbourne, Australia. He is with us. A very warm welcome to you, sir.
Thank you very much. Namaskar, namaste, namaskamaru, wherever people may be in India. I know your welcomes are very different, like all of your people. I'm very honored to be talking with you today.
So guys, Mr. Jonathan is a mathematician who is researching on Indian mathematics, which is called Bharatiya Maths from last 37 years. So I would like to request Mr. Jonathan, sir, that please tell us about how you got interest in Bharatiya Maths and how Bharatiya Maths is different from Western mathematics.
Thank you for the question. I first became interested in the problem of why mathematics is confusing in 1968 when I was a little boy, aged 7, in class 2. What I noticed when I was in class 2 was that Bharat's zero, Bharat's shunya, was missing from my teacher's explanation of mathematics. So later on, I decided in 1983, after noticing many confusing things about mathematics, that we're told to follow rules without necessarily obeying the rules, understanding the rules. We just obey the rules. We memorize formulas without understanding. In 1983, I set out to fix mathematics. The Vedic mathematics was great for giving me some interesting speed mathematics tricks, as they're often called, unfortunately perhaps. But I really wanted to understand how it really worked. Like I wanted to pull mathematics apart as if I was an engineer and understand all of the bricks and the foundations and how it all fitted together. And I didn't ever have that. So I set out in 1983 to try and come up with an explanation of mathematics that would make sense to a child in class 2. So although I've become an old man in the meantime, my goal has always been to be able to explain maths to young children in a way that they will intuitively understand, as if, oh, well, that's simple, that's common sense, I understand that. And so the Bharatiya Mathematics, I kind of came back to the mathematics of India, and along the way, after starting off with Vedic mathematics in 1983, I also explored mathematics in ancient Greek, Sanskrit, Arabic, French, German, Italian, Russian, Dutch, Czech, Spanish, around about 19 different languages. But about 6 years ago, I really started to focus on the mathematics of Aryabhatta, Brahmagupt, and Bhaskara the first. And people had translated their shlokas many times. And people knew about, for example, the laws of sine of Brahmagupta. But nobody had really taken a very simple bird's eye view of mathematics to say, what's the big idea of Brahmagupta? What's the biggest idea of Aryabhatta? What's the biggest idea of Bhaskara? And what I've done is I've simplified the ingredients of Indian mathematics. So now it's almost like I feel I could explain mathematics to my children in the same way that Brahmagupta would have explained mathematics to his children. How is Bharatiya Mathematics different? Well, the mathematics that's taught all around the world is based on a Western understanding of mathematics that came to us via the ancient Greeks. So in particular, you would have heard of names like Euclid and Pythagoras and Thales and so on. And in the Renaissance in Europe, they started to rediscover the mathematics of the ancient Greeks. And what happened is they took, for example, in particular, book 7 of Euclid's Elements as the kind of the Western Bible of arithmetic, because book 7 of Euclid's Elements was an explanation of arithmetic number theory as line segments. So it didn't have any numbers in it, this book of Euclid, but it was about the geometry of line segments, which we would measure today with a ruler. But what happened is the ancient Greeks didn't have any concept of zero. They didn't have the number 1 as a unit. So they had no 0 as a number, they had no 1 as a number, and they had no negative numbers either. And yet that's what Europe and then England took as the foundation of mathematics. And they developed all of their explanations of mathematics without 0, without the number 1, without the concepts of positives and negatives being balanced in symmetry. And that became the way that the British Empire began to spread its mathematics to all of its settlements and colonies around the world. And this is hundreds of years before the writings of Aryabhatta and Bhaskara and Brahmagupta had been translated into the English language. I first met an Indian professor of mathematics in Hungary, strangely enough, and I was speaking at a conference on mathematics in Hungary, and this Indian Dr. S.R. Santanam said he didn't know about this Indian mathematics, and he invited me to tour India. So that was my first tour of India, and you met me on my third tour of India at IISA in Pune.
Right, absolutely. So guys, my dear students, as we discussed and Mr. Jonathan gave us so many knowledge about our Indian ancient mathematics, I just want to say that this is a journey of 500 before years. It's like we can say Shunya to Anant, 0 to infinity. So I just want to ask Mr. Jonathan, because he gave his life 37-38 years for Indian mathematics. All students should be aware of these Brahmagupta journey, Aryabhatta's and Bhaskara Rai's life journey. Sir, could you please tell me how can we introduce Indian ancient mathematics concept in Indian curriculum at primary school?
Well, I'm hoping that Narendra Modi and all of the ministers in the Ministry of Education will watch this video that you're helping me with, Shweta. It's really a case that I'm talking about the ideas of these ancient rishis, but what I'm wanting to do is to convert them into cartoons for children and games and songs for children. So what I'm not going to be doing is focusing on a lot of dry text from the Sanskrit. What we need to do is to entertain children and make the ideas fun. So the fun and games really is all about putting aside the concept of number. It's not about the words, it's not about the symbols, it's about the play. But let me give you a quick example of a game about selling bricks. You know, houses are made from bricks, and imagine that the bricks are made of clay. So imagine a child is a builder, and the child has a spade and a bucket. That's all they've got. And the bucket has square sides to it. Now, the child can dig up the clay and put it into the bucket and fill up the bucket and then turn the bucket upside down, and the sun will dry the clay and make a brick. Okay, so that's how we might imagine a brick is made. We just dig a hole in the ground, fill up our bucket, and the sun will dry that cube-shaped brick of clay into a brick. So imagine a child in class 1 is going to play a game. They're going to sell bricks to another child. And the child who's the brick seller has 2 bricks for sale, okay? But what if the child comes along and says, I want to buy 5 bricks? Oh no. The child wants to buy 5 bricks, but the seller only has 2 bricks. So what will the child do? The child will dig a hole and fill up the bucket and make a brick. And the child will dig 3 holes to make 3 bricks. Okay? So the child then has the 2 bricks at the start plus the 3 bricks that she just made. So she's got 5 bricks now, and she sells them. Okay? And everyone's happy, but guess what the child now has? 3 holes. Okay? So that's a kind of a game that children can just look at bricks and holes and imagine digging with a bucket and a spade. And if we let a brick be like 1 positive and 1 hole being like 1 negative, then we start off with ground level 0, and 1 brick goes up 1 and the hole goes down 1. But if we put the brick in the hole, we get back to ground level 0. So we can have bricks be positives and holes be negatives, and we can get children an understanding of adding and subtracting bricks and making bricks and selling bricks and buying bricks. And before you know it, we can then say, well, let's count how many bricks we've got. And they haven't been writing numbers yet. They haven't been drawing symbols. They've just been playing a game and role-playing these little happy Harappan Valley brick seller games. The least amount of energy you can have is 0. And if numbers represent counts or measures of quantity or energy, the least number representing a quantity you can have is shunya. And so negative numbers are not less than 0. That's the mistake that came in from Europe. So let me leave you with that thought, and in a little while I'll share some slides with you, and I look forward to perhaps maybe later on after the video some questions from the people who watch this. But it's an exciting journey to realize that many of the confusions that you've had are not the confusions, they're not your problem, they're not your weakness, they're not your stupidity or your lack of intelligence. If you were ever confused by mathematics, you were probably right to be confused, because the structural foundations from the West and the British Empire in particular are wrong. So thank you for watching. Thank you, Shweta, and also to eSaral. You've given me a wonderful privilege on National Mathematics Day I wish you all the very best of success in your futures.
This is our honor, sir. You came to address our student on National Mathematics Day. Happy National Mathematics Day to all of my students. Thank you, sir. Thank you so much.
Thank you. See you soon.
Thank you.